All right, today we are looking at parallelograms. So you're going to follow along with me and do this in GeoGebra yourself. So once you are there, you should come down to draw a line. And so we're going to select and draw a line AB. And then also draw a line from B. So click on the point B and just come up somewhere, anywhere up here. So we have a line AB and we have a line BC. They share the point B. The next thing we're going to do is to, right above where it says lines, that we just clicked on, we have construct. And so we're going to construct some parallel lines. So we're going to click on that. It says select a point and parallel line. So you're going to select point C and the line AB. Make sure that you do not select the point A or B. You want to select just somewhere on the line, and you'll see that it constructs a line parallel to A and B. Next, we're going to do the same thing, but with A. So select the point A and the line CB. These two intersect at a point. We're going to put that point there and call it D. And after that, we're going to, this may seem weird, but we're going to actually draw in segments for each of these. So go back down to lines, pick segment, and you're going to draw the segment AB, the segment BC, CD, and AD. And then we're going to clean up the work a little bit here. So we're going to pick each of these lines. If you select, so again, you're using the move tool, select the line. The first thing is a paint bucket. Select the paint bucket and white out the line. And you should be able to do most of them without needing to leave out paint bucket. Now we don't need our sides labeled with I, M, J, and K, but I don't think that it's going to get in our way, so we're going to leave it. So what we have here is a four-sided figure, and the main property that we set with it was that we made opposite sides, the sides across from each other, like M and K, or I'm actually not sure if that's an I or an L. J and lowercase, so it's got to be an I. L. L and J are parallel, or sides DC and AB are parallel, and AB and AD are parallel. So what should we call this figure? A quadrilateral with both pairs of opposite sides parallel? Well, we're going to call it a parallelogram, right? Now, there are certain things that are true about parallelograms, and what you should do with yours that you have drawn is try to investigate this parallelogram and see what things you think might be true. So what is true about a parallelogram that you can see yourself? So I want you to pause the video here, stop the video, and do that. So find what is true about this parallelogram on your own. And then once you have, say, 3 things maybe, or once you try to get 3 things, then you can come back and watch the rest. There are 7 total, but we did talk about 1 already. So we talked about the opposite sides being parallel, and so that one, obviously, you don't need to find. There are 6 more things that are really important, though you might find some other things. So I'm going to put it a different way hopefully before you pause. You're going to try to come up with some conjectures, right? So we talk about this in math a lot, conjecture. So what do you think is true about the parallelogram? And then eventually we're going to try to decide whether or not they have to be true, right? So we're going to test our conjecture. And that is really the basis behind proof in general. So right now, again, you're going to pause the video, decide what you think is true. So hopefully you actually did that, and hopefully you did find some things, right? Well, what kinds of things would we be looking at or looking for? Well, the first thing that you might notice, and if you didn't, hopefully you did some of this like we do when we do this kind of investigating. Well, that seems weird, right? Do we think that this is always true for parallelograms or just the one we have here? Well, if we're not sure, we just play around with it a little bit. And this, the only thing we did with this figure was made opposite sides parallel. So this looks like it's always true, right? That the sides that are across from each other, which we're going to call opposite, that opposite sides are congruent. Well, what else looks like it might work together? So that angle is 59 and some change. That one's 120 and some change. Well, that's weird. Okay, so it looks like, this is again a conjecture, just having it in a diagram like this doesn't prove it, but a conjecture we might make is that it looks like the angles opposite each other, these are across from each other like B and D, and A and C are also congruent, right? So we might make the conjecture that opposite angles are congruent. But there's also something else that's interesting about the angles, and this one might not feel as much like a conjecture because it's something that we know just about parallel lines, and that is that the consecutive angles here, we have a 62, almost 63, and 117. Well, those two angles sum to 180. So consecutive angles are supplementary, right? So we have four features right now of a parallelogram. We have opposite sides being parallel, or a quadrilateral, and that is by definition. That's just what a parallelogram is. And then we have opposite sides congruent, opposite angles congruent, and consecutive angles supplementary. All right, so what else is true? It gets a little bit trickier from here. So what if we had drawn in a diagonal? Now that might seem unfair, right? Mr. Poppy, you didn't say anything about diagonals. Well, okay, but we can always add stuff to a diagram. So, well, now it kind of looks like a problem we would have had when we were proving triangles congruent. And if our conjecture is opposite sides are congruent and opposite angles are congruent, then by side angle side, these two triangles are congruent, right? And so that might be another conjecture we make, right? It looks like when you draw in a single diagonal that you get congruent triangles. Cool. Well, that also should lead us to, oh, well, if we can draw in one diagonal, we can draw in another. And you might make a conjecture here, this one would be wrong, right? But you might make a conjecture here that the diagonals are congruent, because here they kind of look like they are, but we can easily push this so that they don't look congruent, right? But they do something, right? Well, what do they do? Well, if we measure out I know it's getting a little busy in here. If we measure out, we get DE is 3.46, EB is 3.436, just like the other one. And those look to be the same, right? DE and EB are equal. And, well, that means that E must be the midpoint, right? And if we look at AE and EC, we're going to find the same thing. So these diagonals cut each other in half, right? They bisect each other. So again, we have opposite sides parallel, opposite sides congruent, the opposite angles congruent, the consecutive angles supplementary. We have one diagonal cuts the parallelogram into two congruent triangles, and we have that the diagonals are going to bisect each other. And the last conjecture that we want has to do kind of with that consecutive or congruent angles. Let's see if I can get there. Not quite perfect. That's about as close as I can get. So notice if we make one angle, no, I can't quite get there, 90.21, 89.79. If I could get it to 90 exact, right, then this angle, angle D, would also go to 90. So if you have one right angle, then they are all right angles. That's the seventh one.